Hello everyone, this is Rahul Shrestha and I am here to present you the fourth part of the chapter Matter for class 8. So in our last class, we read about the different types of matter that exists in our universe. We read about the impure substances, also known as mixtures, and the pure substances, elements and compounds. Now moving ahead, looking at the contents of the chapter, we should start with the topic types of elements. But instead, I would like to start with a much important topic first, which is atoms. So what are atoms? Atoms are basically the most fundamental unit of matter. It is the most basic building block of all matter. Atoms त्यो सबभन्दा सानो अणु हो जसले गर्दा यो ब्रह्माण्डको हर एक कुरा बनेको छ. Even the things that we cannot see like air or gases, even these are made up of atoms. According to the definition given in your books, it is the smallest particle of an element which can take part in a chemical reaction. For now, you leave this definition aside as I'll get back to this at the later part of our chapter. So previously, the people used to believe that if we try to cut something smaller and smaller, say this apple, then we could do this infinitely and cut this apple smaller and smaller without ever reaching to its smallest size. But this theory did not go well with a particular person named Democritus. In fact, he said that at some point we will reach a particle so small and indestructible that it could not be divided any further. And he named these particles as atmos, which means uncuttable. And this was humanity's first insight into understanding atoms. You can think of atoms as the bricks that we use to create our houses or buildings. Suppose if this building here is matter, then the bricks are the atoms, the most fundamental unit or the building blocks out of which this whole structure of this matter has been built. So everything and anything that exists are made up of these very tiny particles we call as atoms. Even our body is made up of atoms. The different ingredients that we use to make a cookie is made up of atoms. And as we have already discussed, there are in total 118 different types of atoms of 118 different elements that we have discovered so far. Then slowly with the passage of time we understood that atoms of a single element are similar to each other but are different from the atoms of other elements. Which means that if we take a piece of gold and dive deep inside it, we will find that it is made up of millions of similar tiny particles which are basically the atoms of gold. But the atoms of gold are quite different from the atoms of any other element, say iron. And this is true for every single other element or matter which is out there. So now we understand that everything around this universe is made up of atoms. But from where does all these atoms come from? How did the first atom originate? Now in order to understand the origin of atoms, we need to go back in time. To a time billions and billions of years ago when there existed nothing. To the beginning of beginning itself. See, the universe in which we live, everything and anything that exists in this universe, the way everything is right now in here, was not always like this from the very beginning. In fact, there was nothing in the beginning, not even time. I know it is probably quite difficult for you to understand right now, but scientists all around the world actually believe that there was a time in the universe when even time didn't exist. And nor does this universe or space. So this was the time of nothingness, a time of absolute void, a time when nothing was present, no stars, no planets, and yes, not even time, just void. Then, due to some coincidences, something happened, and this something was the Big Bang. And what I think is that these coincidences were nothing but accumulation of energy in some form in a very, very tiny point of an area, even smaller than a pinhead probably. And the energy that got accumulated was so tremendous in quantity that it could no longer contain itself in that small point of an area, and ultimately that point collapsed and the energy got released. And the release of that tremendous amount of energy led to the Big Bang. Now understand that this event, the Big Bang, even if we call it as a bang, was not actually like a bang or the bursting sound that we get from an explosion. Instead, it was just like a sudden expansion of something from a single point. And in this case, the something which was expanding was the universe, which started its journey from a single tiny point. And I don't know if you are aware of this or not, but our universe is still expanding. Like even right now at this very moment, it is expanding, which means that the different stars and galaxies are going farther from each other with every passing second. Now coming back to the Big Bang, as soon as this happened, the debris which came out of this expansion consisted of uncountable numbers of very, very tiny particles known as quarks, which were even tinier than a single atom. Then slowly, taking millions of years after the Big Bang, what happened was that these quarks passing through time and space combined, reacted, and went through a tremendous phase of evolution to form the very first atom of the universe, which were mainly the atoms of hydrogen and helium, which are still the most abundant elements of our universe. Now, atoms in general are made up of much smaller particles known as subatomic particles, which are protons, neutrons, and electrons. The protons and neutrons here forms the central core of the atom called as the nucleus. Here, protons are the positively charged particles, while neutrons are neutral or has zero charge. So the nucleus in totality has a positive charge, as the only charge carrying particle inside it are the protons, which itself are positively charged. Then we have the electrons, which are the negatively charged particles, and these electrons revolve around the nucleus in their own definite path known as cells or orbits. Now atoms generally has the same number of negatively charged electrons around the nucleus as the number of positively charged protons inside the nucleus. And for this reason, the overall charge of an atom is zero. Or you can also say that atoms are electrically neutral. Now if you look at this table here, which shows us the different properties of the subatomic particles, protons are represented by the symbol P+, as they are positively charged. Electrons are represented by E- because they are negatively charged, and neutrons are represented by N0 as they are neutral in charge. In that same manner, the mass of one proton and that of one neutron is 1 AMU. Here, this AMU is the atomic mass unit. It is basically a unit of measuring the masses of very, very tiny particles like atoms, molecules, and subatomic particles. And if you want to know how much of a mass is AMU, then it is equal to 1.661 multiplied by 10 to the power minus 24 of a gram. Which means that you take 1 gram of something, then divide this mass into these many equal parts, and then take one single part out of it. Now the mass of this one part is the mass 1 AMU. This mass is quite small, right? Wait till I explain the mass of an electron. So the mass of one proton as well as one neutron is 1 AMU. And likewise, in order to understand the mass of an electron, now take 1 AMU mass of something, divide this mass into 1837 equal parts. Take one part out of it, and the mass of that one part is the mass of one electron. which is much lesser than that of a proton or a neutron. In fact, the mass of an electron is so small that we don't even consider its mass while calculating the mass of an atom. Now, talking about the mass of an atom, we will be discussing this topic in our forthcoming classes. I hope you found the origin of atom interesting. We'll meet again the next time. Till then, take care and be safe. Thank you.